Before we start creating the dense point cloud, however, we should save the project. We don't want to lose any completed steps. This should be done regularly. If the software crashes, which could likely happen considering the heavy computing, many hours of work and of computing time could easily be lost. If you're unsure whether a certain intermediate state of the calculation would be needed later, these steps can be duplicated. In Metashape, these intermediate steps are called chunks. Duplicate saves a work step that can be later accessed and started from again. At the same time, chunks can also be used to process different parts of a complex object individually, or to divide the photos into different camera types or camera parameters. This makes sense, especially if the photos used were taken at different times. In any case, the step is saved at the copy of chunk, visible to the left of the screen. In the next step, we will calculate the dense point cloud. To do this, we go back to the workflow menu and select Build Dense Point Cloud. During the calculation, medium should be selected here, and it is possible to color the point cloud directly. For example, individual points being assigned as value of the pixels taken from different images. It is very important to select point cloud confidence. We will see in the next step why we need this. Processing is finished in a few minutes, and we do not see any results yet. For this, we select the view for the thin point cloud in the menu bar. The calculation has worked well, and we have an almost complete model made of closely spaced points. Only under the arms or between the knees of the figure we can see some errors. In addition, parts of the markers are still visible in the model. These errors are now also cleaned up. Option 1 would be to do this by hand. To do this, we have a whole range of tools at our disposal with which points can be selected. We now use the freeform selection tool, select all the points we want to delete and remove them. With this object of simple shape, it would only take a few minutes. However, there are much more complex models that would take much more time to clean up. This is particularly problematic because we cannot always see exactly what we have selected and what we have not, as the selection always affects the whole model. Thus, points are often selected in such a way that we also hit areas behind them and unintentionally delete them without noticing. If necessary, we can undo the mistake with the back button. By the way, the small star at the file name indicates that the current status has not been saved. To be sure, we should now save the progress regularly. If we want to stop the point selection, we simply click on an empty area and thus cancel the selection. We do not want to clean up the model completely by hand now, but use the previously calculated point confidence by choosing Dense Cloud Confidence in the menu. Using this command, The statue is now displayed in rainbow colors. The colors show a scale from 1 to 100, with 1 being low confidence and 100 representing high confidence. We now remove all the points with a low trustworthiness to further clean up our object. To do this, we go to the Tools menu and select Dense Cloud Filter by Confidence from the submenu. Here we select a value between 1 and 3 and thus filter out all points with a better trustworthiness. By setting the Select Confidence range between minimum 0 and maximum 255 in the menu under Dense Point Cloud, we now see all faulty points. Now we could simply select all the still visible points and delete them. However, if too many points were selected, we would lose them and would have to perform the Dense Point Cloud calculation again. Therefore, we choose another method. Most of these points are in areas that the camera could not reach particularly well, or they are part of the background, which we don't want to become part of our model. With the selection tool, we can highlight all points. By clicking into the screen with the right mouse button, under Assign Class, we define the selected points as high noise and then deselect the points. Then we click under Tools, Dense Point Cloud on Reset Filter to make all points visible again. Now we can look at the classes of the classified points by choosing Dense Cloud Classes. From this we can see that we have two different classes, here in colors gray and pink. The gray points are the points of our model, and the pink points are the ones with the lower trustworthiness. We can now hide these with a filter under Dense Point Cloud, Filter by Class. We can still remove the last errors in the model manually using the Selection tool. The model now has only a few small errors, which we'll address in the next steps when we create the grid and the texture. We now have a complete model of the statue that is made of a dense point cloud. Zooming in, we can see that this is not yet a closed surface, but countless points describing the geometric shape of the object. But since all objects in the real world have a closed surface with texture, this is our next challenge. To connect the points with the mesh, we select Build Mesh from the Workflow menu. Texture can then be applied to the surfaces created by the mesh. As a base, we select our dense point cloud and choose Arbitrary, which is useful for an unstructured grid. There are other options to choose from, but they are for different purposes. For a complete 3D object, the setting should be left as given. However, the face count, meaning the sum of individual surfaces, should be set to high. Reducing the surfaces only makes sense if you are working on a very weak computer. We can color the geometry directly by selecting Calculate Vertex Color. Very important now is the setting of the point classes. In the previous step, we moved the faulty points to the high noise class, and now, of course, we do not want to include them in the next calculation step. So we select high noise under the point classes tab. This calculation should only take a few seconds, but this again depends on the performance of the computer used. Clicking on the next icon in our menu, the pyramid, we can look at the model as a closed geometry. By rotating and zooming the figure, it is noticeable that we have created a very accurate model. The small holes and imperfections are now no longer visible. This automatic removal of defects is very practical, but of course it changes our model compared to the original. We should keep that in mind for further use. We can also have a look at the model in a colored view. However, this is only a colorization of the individual triangles of our mesh, and as we can see, the quality is not particularly high. For accurate texturing, we need to take another step by selecting the next item in the workflow menu, Build Texture. Under this command, we can select different texture types, the source of the color values, the type of conversion, and the complexity of the texture. For the most part, we leave it at the default settings, but set the texture to a lower resolution at the count of 1, which is sufficient for us. Subsequently, we derive a photorealistic surface from the images that completely encompasses the model. We leave the settings the same in this case and start the calculation. We can now select the textured model from the menu. As a result, we see the photorealistic virtual copy of our object, which can now be further used in many different contexts.